Welcome to 4.6 notes on modeling direct variation. We have two vocab terms for this section. The first one is called direct variation. So we're going to talk about what that means. It means that there's a relationship of two variables, and they are x and y, or they could be whatever variables, but we use x and y when we're graphing, provided that y equals a times x, and a can't be 0. Now this is kind of like slope-intercept form, but now there's an a there instead of the m, but it means the same thing. They just changed m to a because it's called something new. It's called direct variation. So here's my y equals mx plus b model, my slope-intercept form, and you notice in y equals ax there is no b. I, a lot of times, use y equals kx because most books and mathematicians will use k instead of a. You need to be prepared that if you saw a, m, or k, they all are talking about the slope, the term in front of the x term. Okay? Now the constant, that k or that a or that m, is that term in front of x, and that's called the constant of the variation. Okay? Well, think about what the graph would look like. If b isn't there, what is it really? It's 0, right? So that means the y-intercept is 0. So what would the graph look like? It would go through where? It would go through the origin. There's no b, so it must be 0. So that means the graph goes through the origin. And we're going to talk about the graphs in a second. The first thing, though, that we're going to do here in example 1 is we're going to identify whether or not an equation represents direct variation. So does it meet this y equals kx model? Well, you need to get y by itself to see. So this first equation, they have the work here, and they're going to subtract 4x to both sides. So we have 2y equals negative 4x. Divide by 2, and then simplify, so y equals negative 2x. To put in our work here, we subtracted 4x from both sides. Now, is this in y equals kx form? Sure it is. So this can be written in the right form, so it does represent direct variation. And that constant is what number? It's negative 2. It could have been a fraction. We could even say negative 2 over 1, but the b is 0. This is going to go through the origin, so it's called direct variation. Now let's look at example B here. The work is down here. You're going to add 2x to both sides. And what happens? There's a plus 3 there. The b is 3, not 0. So it can't be written in y equals kx form or y equals ax form. So it does not represent direct variation. Does not represent direct variation. Okay, so go ahead on the next page here, do these two problems. Tell me whether or not it represents direct variation, and if it does, identify the constant. Pause the video, and then I'll show you the answers. Okay, so here's our answers. Number 1, yes, it does, and its constant is negative 3/4. And number 2, no, it does not, because there's a plus 1 over there, and there's no constant, obviously. That one's in slope-intercept form. It's not direct variation. Okay, now we're going to talk about graphing when it's direct variation. It's already in slope-intercept form for us here, so that's very nice. And so if I identify my m and my b, we're kind of going to go back to m here. What's m? It's negative 5. But I want it as rise over run, so it's negative 5 over 1. We like to put the negative with the number on top. My b, what is it? It's a direct variation equation, so b is 0. So where do I start? I start at the origin. Okay? So then I go rise over run, down 5 over 1. There's my 2 points. Use my ruler and connect. Direct variation equations to graph are even easier than regular slope-intercept form ones because they're all going through the origin. And then you could talk about your predictions. Yes, it went through the origin. Yes, it's going down because the slope is negative. Yes, it's steep because 5 is bigger than 1. And then just fitting this number in here for your notes for later, that would be the negative 5 there. Okay, The next one I'll graph in a different color here. It's y equals 3/5 x. They give us room to graph it right here. So our constant is 3/5. That's otherwise known as the slope. So m is 3/5, b is 0. Start at 0, 0. Rise over run, so we go up 3, right 5 this time. It's not steep. It's going up, and it's crossing the origin. It's meeting all of my predictions. Okay, so we're going to go to the next page, and I want you to practice number 3 right here. Go ahead and pause, and then take a look at my answer when you're ready to make sure that you graphed it correctly. Okay, here's the answer to this one. We have our m is 1/2. Our b is 0. It went through the origin, up 1 over 2, up 1 over 2, and so on. Okay, the last topic for this section is if we had to write a direct variation equation. So we are looking at this graph, and you know, oops, let's move it down. You know it's a direct variation equation because y, it's crossing through the origin. So you know it's y equals some kind of kx. So what you're going to do is you're going to pick any point on the line. That's a nice one where you can tell, and they gave us a nice one right here of -4, 3. We know a direct variation equation comes in the form y equals ax or kx or mx. We don't know this a. Now we could count it, but I'm going to show you how to do it if you didn't have a graph, because down there at number 4, there's not actually a graph. So y equals kx. Well, what is the y coordinate right there? It's -3. What is the x coordinate right here? It's -4. So I plug in for x and y. Any nice point on this line. See right here? That's another nice point. That was 4, 3. It would have worked as well. So what I have, I'm going to just kind of do my work off to the side here. I have -3 equals -4a or k or whatever letter you're using. Divide both sides by -4. And -3 over -4 simplifies to 3/4. So that's the constant. So then all you need to do is write y equals 3/4 x. Now if they said, when x is 80, what would y be? Well, it doesn't go up on the graph up to 80. So all you would do then is take this 80 and plug it into the equation there. So to do my work off to the side, y equals 3/4 times 80, or you could do 80 over 1. They both can be divided by 4, so 4 divided by 4 is 1. 80 divided by 4 is 20, so I'm left with y equals 60. And you could have multiplied it out and then reduced it if you wanted. So y equals 60. They wanted me to put my work in here. That's why there's 2 blanks. Okay, so what you're going to do down here on number 4 is you're going to do the same thing. It's y equals kx or y equals ax. Here's your x, here's your y. Plug them in, find the equation, and then once you do, see what it would be when x is 15. All right, so here's my answers. I plugged -4 in for y and 3 in for x. Divide by 3, and my constant ends up being -4/3. So here's my equation. Now, if x was 15, I plug it in, and it simplifies to y being -20. Okay, that's it. See Mrs. Wyman if you have a question about the notes. Otherwise, you are continuing on to this next page. And I was able to squeeze all of my work in on this page, so hopefully you're able to as well. I didn't give you a work page on this one, so sorry, but just kind of previewing. You're not going to just pause it and copy all my answers, but you can see that I have the work squeezed in here and then also there. And then when I graphed them in different colors so that I could kind of identify. I also wrote the equations up at the top of each one so I could see what was what. Okay? Have at it.